All right, 6th grade, moving along here in Chapter 2, Lesson 2.3 with fractions. I'm just going to review these real quick, then we're going to get right into them. The only difference between what we did yesterday in 2.2 and what we're doing today in Lesson 2.3 is that we are bringing mixed numbers into the fold. Our dividing of fractions and whole numbers is now also going to include mixed numbers, but our rules do not change, and I'm going to read through them again before we get started. Steps of dividing fractions. Step 1, make everything a fraction. Step 2, make the reciprocal of the divisor. Step 3, make the division sign a multiplication sign. Step 4, cross-check. Step 5, multiply. Step 6, simplify. So those are our steps. We're going to become more and more familiar with those, but you should be feeling pretty good about those. So put that to the side, and let's start looking at our example problem. So we're going to start with this one, 7 5/9 divided by 4 over 7. Now we talked about back earlier in Chapter 2, when we take a mixed number and turn it into a fraction, it is the denominator, which in this case is 9, times the whole number, which in this case is 7. So 9 times 7 is 63. Then I'm going to add the 5 to that, and 63 plus 5 is 68. So this is going to become 68 over 9. 9 times 7 is 63. 63 plus 5 is 68. My denominator 9 is going to stay the same. My division sign is going to become a multiplication sign. Remember, all we're doing when we divide fractions and mixed numbers is turning the division problem into a multiplication sign. My 4 over 7 is going to become 7 over 4. All right, so now I want to think about cross-checking, and I really want to think about cross-checking because I'm thinking 68 times 7 is going to be a way bigger number than I want to use. That's the advantage of cross-checking, is you can make smaller numbers, and smaller numbers make it easier. And whenever you get a teacher telling you to make it easier, that's a good thing. But unfortunately, I can't cross-check a 9 and a 7 because there is no number besides 1 that can go into both 9 and 7. Okay? So I can't change those. So let's think about 4 and 68. Now, when I think about my rules of divisibility, I realize that both of those numbers are divisible by 2 because they are even. So I'm going to think, well, 4 divided by 2 is 2. I might have to do a little scratch work to come over here and do 68 divided by 2. Some of you may not need to do that, but we'll do that just in case. 2 can go into 6. 3 times 2 is 6. 6 minus 6 is 0. I'm going to bring the 8 down. 2 can go into 8 4 times, and as a 6th grader, I know that 2 times 4 is 8, so I can be confident that 34 is the correct answer. But when I'm looking at that, I see again, well, I have 2 and 34. Because if I take that 68 then, and I've divided it by 2 and make 34, I still have 2 even numbers. This ends in a 2, this ends in a 4. Okay, you may not always get the right number the first time. Okay, especially with mixed numbers when the numbers are a little bit bigger, but that's okay. That's not a problem, 6th grade, but you just have to have the patience and you have to be careful to check for that. So I can see that they're both even numbers, so I can divide them by 2 again. Well, I know that 2 divided by 2 is 1. Then if I take 34 and divide it by 2, I'm going to bring that over here, 34, divide that by 2. 2 can go into 3 one time. 1 times 2 is 2. 3 minus 2 is 1. I'm going to bring the 4 down. I can see that 2 can go into 14. 7 times, there's none left over. I can be confident because I know that 7 times 2 is 14. And sure enough, 34 divided by 2 is 17. So I end up with that. Now I need to multiply. And I'm going to start first by doing 17 times 7. Well, that's probably going to involve a little bit of scratch work. So I'm going to come up here, 17 times 7. Well, 7 times 7 is 49. put the 9 down, carry the 4. 7 times 1 is 7, plus 4 is 11. I get 119. I'm going to come over here. 17 times 7 equals 119. Well, 9 times 1 is 9. All right? So now I have an improper fraction. Now what I can be is confident that it's in simplest form. Because remember, by definition, simplest form simply means the only number that can go into both the numerator and the denominator is 1. Simplest form has nothing to do with this being bigger than that. However, I do know that when it's an improper fraction, I want to make it a mixed number. So I get 119 divided by 9. So I'm going to come down here, 119 divided by 9. Well, 9 can't go into 1, but 9 can go into 11 one time. Okay? 9 times 1 is 9. 11 minus 9 is 2. I'm going to take this 9 and bring it down. 9 can go into 29 3 times. And I know that because 3 times 9 is 27. 29 minus 27 is 2. I end up with a remainder of 2, which is okay when I'm dividing by 9. Now, how do I take this and turn it into a mixed number? Well, we saw that 9 can go into 119 13 times. If I take 9 into 119 13 times, there are 2 left over. That's my numerator. My denominator here was 9. I was dividing by 9. My denominator there is going to be 9. I end up with 13 2/9. All right, moving right along. 7 1/5 divided by 8. Well, 5 times 7 is 35, plus 1 is 36. So that's going to give me 36 over 5. My division sign is going to become a multiplication sign. 8 would have started out as 8 over 1, but I have to make the reciprocal. I have to flip it. So it's actually going to become times 1 over 8. Okay, well, thinking about cross-checking, that's a 1. So that's going to give me a clue that I cannot cross-check a 1 and a 5. That's not going to get any lower. But when I think about my division and multiplication tables, I think of the, well, 36 and 8 are both divisible by 4. They both show up as answers in my 4 times table. So if I divide them both by 4, 36 divided by 4 is 9. 8 divided by 4 is 2. All right, and I don't think 2 and 9 can go any smaller, so I'm pretty confident that I can go ahead and multiply. Well, 9 times 1 is equal to 9, and 5 times 2 is equal to 10. It's not an improper fraction, and sure enough, the only number that can go into both 9 and 10 is 1. That's the joy of it. Sometimes you get ones like the one we did first, all sorts of scratch work. Sometimes you get ones like these, 6th grade. So just have to be willing to do the work, and as long as you do it right, you'll be fine. All right, we got a couple more. 7 over 8 divided by 3 and 1 over 16. Well, 7 over 8 is already a fraction, so that's going to stay the same because that's the first one. My division sign is going to become a multiplication sign. When I think of 3 and 1 over 16, it is a mixed number that I need to turn into a fraction. Well, 16 times 3 is 48. Some of you may need to do some scratch work on a problem like that. But for time purposes, on just showing you what to do, I can tell you that 16 times 3 is 48. 48 plus 1 is 49. So this would be 49 over 16. If I was to make that a fraction, it would be 49 over 16. Once again, 16 times 3 is 48. 48 plus 1 is 49. 49 over 16. But then I'm going to flip that 49 over 16, and that's going to become 16 over 49 because I have to make the inverse or the reciprocal. So now it's time to start thinking about cross-checking. Well, with 7 and 49, I know that they're both divisible by 7 because I know that 7 times 7 is 49. 7 divided by 7 is 1. 49 divided by 7 is 7. 8 and 16, I know those are both divisible by 8 because 8 times 2 is 16. So 16 divided by 8 is 2. And 8 divided by 8 is 1. So now that I've significantly made those digits much smaller. So this is just a great time to pause 6th grade and just show you why cross-checking is a good idea. Because I would have done 7 times 16 and gotten 112. I would have done 8 times 49 and gotten 392. Okay, so 112 over 392 is not what I would have wanted to deal with. Okay? Much easier to cross-check. Now I can go ahead and multiply. 1 times 2 is 2. Some weird lighting things going on there. 1 times 7 is 7. I can be confident because these were as small as they can get. 2 over 7 is in simplest form. The only number that can go into both 2 and 7 is 1. It is not an improper fraction. That needs to be turned into a mixed number because the 2 is smaller than the 7. Last one, 2 mixed numbers, 6 and 2/9 divided by 5 and 5/6. Well, first I need to turn them both into fractions. 9 times 6 is 54. 54 plus 2 is 56. So I get 56 over 9. 6 times 5 is 30. 30 plus 5 is 35. I get 35. Come over here. 35 over 6. Okay? And my division sign becomes a multiplication sign. My 35 over 6, I need to make the reciprocal or the inverse fraction. 35 over 6 becomes 6 over 35. And I like that because I'm looking at those and as a 6th grader, once again, we want to know our multiplication tables really well. We should be able to realize that like 9 and 6, they're both divisible by 3. Sure enough, 6 divided by 3 is 2. 9 divided by 3 is 3. 56 and 35, they both look like answers from the 7 times tables. 56 divided by 7 is 8. 35 divided by 7 is 5. I can't make an 8 and a 5 any lower. Not a common factor of 2 and 3 is any lower, just 1 for both sets there. So I can go ahead and multiply. 8 times 2, 8 times 2, 16. 3 times 5, 15. It is in simplest form because the only number that can go into both 16 and 15 is 1. However, it's an improper fraction because 16 is bigger than 15. So I've got to actually do 16 divided by 15, which is pretty straightforward. 15 can go into 16 one time. If I take 15 into 16 one time, I have 1 left over because we know that 15 plus 1 is 16. My denominator here is 15, so my denominator there is 15, and I can be confident that it's in simplest form. 1 and 1 over 15 is my final answer. All right. Tomorrow, adding and subtracting decimals, moving on from operations with fractions to operations with decimals. All right. Talk to you later, 6th grade. Bye.